Hello, in this short video we are going to investigate the following challenging problem on the topic of evaluating definite integrals. If I is equal to this definite integral, then cosine inverse of I plus 1 is equal to. Pause the video at this point and give it a try to see which one of the following options is the correct answer to the problem. Okay, I want to use method of substitution for solving this integral, or you can say the change of variable. If you pay a little bit attention to the problem, you see that's a good idea if you take this ln of sine ln of x as your new variable, so let me call it t. Why is that? Because if you are good in differentiation, you immediately realize that if you take this to be your new variable, the derivative of this expression somehow appears as a factor in your integrand. So you know whenever this happens, the method of changing the variable or substitution method is extremely helpful. So why this is the case? So let me differentiate now both sides. To differentiate the left-hand side, I have to use the chain rule repeatedly. So for example, let us take that in my head this is u, and then on the left hand side I have ln of u, and the derivative of ln of u is just simply u prime over u. Okay, so let us do that. So this becomes u prime divided by u itself, but of course multiplied by dx. The right hand side also becomes dt. But now I have to differentiate this function. Now I will give the role of u to this, and then I will have sine of u prime, so it becomes cosine of u, but because of the chain rule I have to multiply it by u prime. Okay, so this becomes cosine of u multiplied by u prime divided by the denominator sine of ln of x times dx equals to dt. But this one is very simple, so you know that the derivative of ln of x is just simply 1 over x, and this x goes to the denominator. So what I will have is cosine ln of x divided by x sine ln of x multiplied by dx equals to dt. And then you see that this is a very good choice. Why? Because this part that you see is exactly dt, and then this one is t. So this is simply sine t dt, which is extremely easy to calculate. But because I have changed my variable from x to t, accordingly I have to change the limits of integration to something suitable for the change in t. And that is also extremely simple. So I would say that x varies from e to power pi over 6 to e to power pi over 2. So what does this imply for t? That's easy. So what we do, okay, I would say that if x is e to power pi over 6, I put it here to see what t is. But ln of e to power pi over 6 goes behind ln, so it becomes ln of e, and this one is 1. So this becomes sine of pi over 6. Sine of pi over 6 is 1/2, so t becomes ln of 1/2. So this becomes ln of 1/2, which can also be written minus ln of 2. And now what happens if x is this number? I put x here. Ln of e to power pi over 2 becomes pi over 2. Sine of pi over 2 is 1, and ln of 1 is 0. So this becomes 0. So now my integral becomes equal to integral from minus ln of 2 to 0. But this becomes sine. Instead of this guy, I just put t, and instead of this guy, as I told you before, I put dt. So this becomes integral of sine t dt. But that also becomes minus cosine t, that I have to run it from minus ln of 2 to 0. So if I put 0, so it becomes minus cosine of 0, and then plus cosine of minus ln of 2. But cosine of 0 is 1, so it becomes minus 1. And you know that cosine of minus theta is equal to cosine of theta itself. So this means that for the second one, I can simply write cosine of ln of 2. So this is my I. So I realize that I is equal to minus 1 plus cosine ln of 2. But look, in the problem, they are asking you what is cosine inverse of I plus 1. So I need to find I plus 1 first. So I add 1 unit to both sides. So I plus 1 becomes simply cosine of ln of 2. Yes? And then I want cosine inverse of I plus 1. So it becomes ln of 2. So that is the answer to the problem. So this means that option C is the correct answer to the problem. I hope that the video was useful for you. Until the next video, be safe and goodbye. Thank you.